All right, hope you guys are doing well today. Here comes another rendition of Zephyr 101. We're going to be talking about HTTPS, so HTTP over TLS. This has been something that I've been wanting to do for a while, just never really had a chance to do it. So hopefully we will jump into that. It looks like I'm having some issues with the stream. All right, just want to make sure for whatever reason, it's delayed on my screen. But as long as it's coming over to you guys okay, we will continue on. Aloha, Scott. So, let's jump in. If you haven't already subscribed, hit that subscribe button. We're getting pretty close to 2K, which is awesome. I think I'll probably do another NRF 9160 feather giveaway if we get there. So, if you haven't already, hit that subscribe button and we'll have a giveaway soon when that happens. And hit the like button. Also, let me know what you think about this particular episode of Zephyr 101, and if you have any suggestions for things that you'd like to see me cover in future episodes, please leave a message below, and I'll try to incorporate it into the next. With Zephyr, it does have an HTTP client per se. There's literally only one function. So a lot of it's setting up a struct and then executing a function command. And you also need to set up the socket and the TLS stuff beforehand before you even use that HTTP client. So a lot of it's not as easy to use and not as abstracted away if you compared to, say, the MQTT client or even a CoAP. CoAP by itself is also pretty finicky, but there are some options in there for everybody. We're going to be going over HTTP. I'm going to be focusing on using the NRF 9160, using the offloaded TLS, just because it's slightly easier. It gets you get a little bit less stuff going on, but still fairly complicated and annoying. So I'll be assuming you have an NRF 91XX, either 60, 61. You have a SIM, you've configured everything, you're connected, you've got access to the internet, you're connected somehow. Here's the steps or the process here. We're going to be setting up a socket. We're setting up TLS, establishing a connection, a secure connection, I should say. We've kind of set up a request, and then we're going to send that request over, handle any data that comes back through a callback, and then closing the socket. So in general, at least for this particular situation here, I'm going to be closing the socket. It's kind of like a wake up, push, and then go back to sleep. By default, HTTPS or HTTP 1.1 it's on or kept active by default. And you don't want to keep that on because it'll prevent your modem from going to sleep. So this is particularly important for the NRF 9160, as I have found out recently. The very basic thing, so those first three requirements are just if you want to use JSON, CJSON. The last one is the library that we are interested in here to talk about. So, but I'm going to run you guys through all kind of the steps in the process, trying to cut out some things that you can go and look at the example yourself. If you go to the description box below, I've actually included a link to the sample that works with the NRF 9160 feather, but it should work with any other NRF 9160. And if you modify it a little bit, you can get it working with embedded PLS, and good stuff can happen there too. Excuse me. This is in main C. So what I'm doing here is I'm just setting up a basic timer and a semaphore to control that timer to kind of create a cloud publish event. This is something that I've gone over in the past, a couple links in the description box below, but this is just handling the flow of the application. I just wanted to show this to you guys because it's always good to kind of review these things as we go. So created this timer, and then a semaphore is actually going to be used to do a publish from the main thread. So we're starting it. It's on a recurring basis using the config default delay. I believe it's 1,440 minutes. which is whatever that is in, I think it's 24 hours. And you can see I'm giving that semaphore first thing, so it'll allow that loop to accomplish at least one full iteration, and then it'll sit and wait forever until you give that semaphore again through the timer. But this cloud publish, this is where all the magic happens, and this is where we're going to be talking about the HTTP client, and then setting up the secure connection as well. So recapping this section, I'm going to try to do this in bite-sized pieces here, so because there's a bunch of things going on. So I'll give you a bunch of code, a bunch of things what's happening, and I'll give you kind of a review of each section as we go. So we've set up a recurring timer. Recurring timer gives a semaphore. The main loop is being blocked in an infinite loop with a semaphore that waits forever. And so on every config default delay, 1,440 minutes or 24 hours, it'll publish a new data point. In this case, the data point is just a binary Boolean. It's just kind of bogus data, just to give you guys a concept of it at least. One thing that, I've created this kind of cloud module, I guess you could say, where you need to initialize it. One thing that I've provided is a parameter for the cloud initialization, and this is a callback. This callback allows you to call a function back in main when you actually have data that has come through the HTTP requests. So, and then another thing here is you can see that provisioning the certificate, and this is interesting because this allows you to load a CA certificate into your code as part of the flash or as part of the binary, and then loading it into the secure key store in the NF9160. Since it's a CA cert, it's not a big deal, and it makes it a little bit easier. You don't have to load it separately over command line or anything like that. It's kind of built into your code. You can see here I'm using the modem key management APIs for the NF9160, so it's a little bit different. There is a TLS key store API that you can use for handling it if you want to load it into memory if you're using embed TLS. I will not be going over that in this particular rendition, but again, anything you guys hear me talk about that seems interesting and you'd like to see more of it, please leave a comment. So we're going to be checking if that tag, so tags, TLS tags is basically just a way of saying, giving a number to a set of tags for TLS connection. So in this case, I'm just using 42. It could be any kind of number that you would like to specify. You got to watch out and make sure that those numbers do not coincide with maybe another service or something else that might be running on your device. So setting them to a particular number that you say, okay, 42 is my TLS cert number. This also applies to pre-shared keys or anything like that, and it's consistent across the ideas of using secure key store on the NF9160 versus using the kind of built-in Zephyr in-memory key store. Same idea works here. It's compatible across those two things. So we just want to make sure it exists, and then we're also doing just a quick comparison to make sure that it matches and it's correct. Delete it if it doesn't match, and then we just load it at the end here just to make sure it's all loaded and happy. If it's loaded and it matches, then we just kind of skip this altogether. So this can be done once and done during your application. Every time it boots, it just checks to make sure it's consistent, but generally you only have to do it once, which is really nice. So we've initialized the cloud client, I guess you could say, with a callback. We're also setting up the provision the can't talk today. Provision the certificate only if it's changed, or if it's not there, you just pop it in there and you just reuse the modem key management API, and it'll do all the work for you. So you can check out the code itself just to see how that flow works. You check out that particular function, which is the cert_provision function. I believe it's in the cloud.c. So one thing I would just want to add is that it's not recommended for private client keys. So if you have a device that's capable of secure key storage, then I would definitely not want to load those into any type of flash or memory or anything like that. In those particular instances, you do want to load them over some type of CLI interface, or the NRF9160 in general, now past modem firmware 1.3.4 or 5, you can actually generate keys on the device itself. So that's really nice. This is the callback, that is the cloud callback. So this is what gets called if you actually get any data returned to you in the kind of cloud client using HTTP. So I just put this here just to give you an idea of, okay, this is kind of what the cloud callback looks like. You generally you want to format the data into some type of struct, so you can provide that to the end user and the main, and you can do things with it or whatever you need to, change a configuration or update a timer or things like that. Here is the cloud publish function. I've removed some things just to get it out of the way. Mostly it's just kind of setting defaults or setting errors and things like that. It's just not really necessary for the situation. Basic usage of CJSON, creating an object. We're adding that something to the object. So this is all being done on the heap. Anything memory allocated in CJSON is done on the heap, for better, for worse. In this case, we have one Boolean, which is called do something, and we're just using that value and we're just adding it to the JSON. Once you have printed the unformatted text, so I like printing unformatted because there's a lot less characters, there's a lot less fluff in there. You're not sending those over the wire and it's not costing you money. So we delete the object. So that's one thing we have to delete. But when you call any function, any CJSON print or print unformatted, you are allocated memory to the heap and you will need to free it later on whenever you're done with it. This is the only drawback that I cringe a little bit every time I use CJSON, but it is what it is. So, oh, I gotta change that. Speaking of free, I'm using the wrong free here. You should be using CJSON free instead of the free that is provided by the kernel, because it will not work. So bear that in mind. So don't look at that. Cover your eyes. But we can set up the socket at least, and we can go to that step next. So here is the socket setup at least the beginning of it here. There are some important things we just want to provide at the beginning. This address info structure. We can set what like network family, either a regular IPv4 or IPv6, and with the socket type. So generally TCP is a stream, UDP is a of course, I'm having a brain fart right now, but I'm going to pull it up because I want to know now. Cloud.c. I want to see datagram. That's what I wanted. So there's a sock underscore datagram. So, and there's also sock underscore raw. So those are some of the interesting information, the different socket types. One thing you want to keep in mind for the socket types is when you use raw, it also includes any of the other supporting data that's in that kind of payload. So if you are doing some type of your own processing on the data as it comes in, that might be useful for you, but most of the time you want to be using stream. If you're using TCP or TCP or UDP for datagram. So let's see. Voxorin, you're using JSMN, no heap, so that's fantastic. For embedded, you know, I know people like using the heap in Zephyr, but let's avoid it, everybody. I think it'll be better for everyone. The next step here is getting the address info. So this POSIX call essentially is just a wrapper around the call that goes to the kernel in Zephyr, but we want to get the the IP address for the particular host name. In this case, it's this circuitdojo.com. So we're going to look up the address for circuitdojo.com. It's going to give us an IP address, and then we can kind of go from there. But this function is used to do any kind of DNS lookups. And then you can see here, I'm just for the I'm setting the port number as well, and I'm just providing that in the kconfig. In this case, it's just 443, the same as HTTPS. Then we can create the socket. Depending on what IP address you end up getting returned from that get address, you could have an IPv6 or IPv4. So it'll also return what family it is, that AI_family. That's why you can use that here, because it's a little more dynamic versus just setting the family. And if you have an IPv6 and you're using the wrong family, you're going to get a bad connection. It's not going to work. We're using stock stream, and we're using TLS 1.2. So, and that's just kind of setting the stage. We're just kind of initializing the socket. We haven't made any connections yet. And for some of you, this is crazy, this is complicated, but to take a step back here, it's like, this is how every connection that you make on your computer or any of your devices, this is kind of how it works. You're setting up a socket, which is kind of an endpoint that you can write and read from, but then everything else kind of stacks on top of it. And that's why they call it like a network stack, is that you have little pieces that sit on top of that socket as you go. So we've created and encoded some data with CJSON. We get the address using getAddressInfo that POSIX call. We create the socket with the TLS options, and then, depending on what you get, you either get an IPv4 or IPv6. And then what we're going to do next is actually set some options for the connection. In particular, we're going to be setting options related to TLS, because we've set that TLS flag, but we have to kind of figure out, okay, what do we need to set for this to work? All of the TLS related items are provided in that TLS setup function, and we're just pointing the number that was assigned by Zephyr for that socket. That FD is just the socket number, or the socket reference that you can use to establish and edit and update the socket as you go. Some of these in here are important. These are just kind of the values that you want to write later on. Sometimes you can actually just put the actual macros rather than using the integers, but in this case, I just set them up at the top. Another thing here is I mentioned the security tags earlier. Those are the tag. That's the important part about looking up the certificate, whatever certificates you're using. So you can actually use multiple, so you can put them in an array. In this case, I'm only using one. So, and that when you do provide that entry, you provide it as an array. This first one, TLS pure verify. So we're using set sock option for this function for everything, but that third parameter is actually defining what we are setting. So in this case, we just want to make sure that we're verifying. That was the option earlier here, that one in the middle, TLS pure verify required. So all we're doing is making sure that the CA cert provided at the particular security tag, watch out, this might get confusing. TLS cert that's provided at that security tag is the same one that is being provided by the server. So all it's doing is making sure, hey, I have this cert for the server. Does this cert match the server? And if it doesn't, it'll actually terminate the connection, which is great because it's just one kind of security check that you can go through. Here is what I'm referring to is the security tag list. We're providing the tag list and also the size of the tag list, and that allows you to set up multiple tags for this particular connection if need be. One thing that I like to do in an embedded world is that you can set up a Zephyr suite list. So what you can do is make sure that between your server and your device, you can see, okay, what ciphers are in common with these, and then set whichever one predetermined on the device. So, hey, when it sends a client hello, it says, hey, I am using this Zephyr suite, take it or leave it. and then the server will say, okay, yeah, cool, I'll use it, or it'll reject it if it doesn't support that Zephyr suite. It reduces the amount of data usage when you're setting that TLS handshake, that client hello, and it just makes it a little bit easier and defined for the server side to come back and be like, all right, yeah, cool, let's go. And for anything that uses a connection with a wildcard host, so say you have a wildcard TLS certificate that you're hosting multiple subdomains and your server is running on one of those subdomains. Or if you're running, let's say you're running multiple domains on one IP address, one thing you can do is, in order to provide or connect to that server and connect to the particular server that you want to. So let me explain this a little bit better. You have a server that's running a reverse proxy that has multiple servers on the backside of it that it's providing a connection to. So you have domain 1.circuitdojo.com, subdomain 2.circuitdojo.com, and what you need to make sure is that domain name information is provided in that connection attempt, so we know what domain you're actually trying to connect to. Because earlier, if you look back, when we looked up the address using the get address info, we're getting an IP address. So we look up the subdomain, we look up the full domain, even if it's a subdomain, we're getting an IP address. But that IP address might be hosting thousands of websites. So you want to make sure that when you're establishing that TLS connection, that information is passed along during the connection stage, during the TLS handshake, so we know what we're actually connecting to. Because you also could have multiple different certificates on your reverse proxy or whatever is hosting your site. So hopefully I didn't make it too confusing, but that is a critical thing, and that will throw you off a lot if this is your first time. I've definitely seen it. I've also seen little finicky situations where I can't connect to a particular server that I wanted because I didn't have SNI or server name identification as a feature for the TLS implementation I was using. This is a while ago. The modem firmware on the NF91 did not have that. So they did add it. They've been slowly adding TLS features as they've been going. I think they're all mostly implemented now. I think except for, I think renegotiation is not turned on. And also session cache might not be implemented either. But as you can see here, I've also just set it as well. Because if there's any way of decreasing the amount of data when you are reconnecting to a particular server, it'll save you some moolah in the end. So especially if you're going to be sending data multiple times a day, every minute, that's really going to add up. And that's when you start thinking about, okay, maybe I just need to switch over to a much more data-friendly protocol using data-friendly encodings like CBOR and using CoAP and things like that. So far we've set the verify parameter so that we're going to be checking. We're checking for the CA cert. We're making sure that it matches the one that we expect when we're connecting to the server. It's just kind of like a double checking, make sure there's no like man in the middle attack or anything like that. Setting up which TLS tag we want to use. We're setting up the Zephyr suite to reduce the amount of data that we use. And in general, you are going to test this beforehand, so you're going to know what Zephyr suite is compatible for both ends. We're setting up the host name for SNI, which is extremely useful for multiple domains that are hosted on a same IP address, wildcard domains, so on and so forth. And then allowing for session cache so we can kind of reconnect without incurring a lot of overhead. Finally, we can actually call the connect function. So this takes everything that you've done so far and actually turns it into a connection where you're actually going to connect over TCP first, then you're going to establish a TLS connection. TLS connection actually requires a handshake, which is a correct me if I'm wrong, guys, 7-step process. So it's a client hello, server hello, kind of a back and forth process to establish a secure connection before you actually start sending actual data. So, and this can incur I keep harping on it, but this can occur like kilobytes of data usage. So at least for TLS. Oop. I think let's try that again. So this is the good stuff. This is what we're getting to here. So this is the HTTP request. This is the structure that we're using to call the HTTPS, and provide all the data and all the inputs to get an HTTPS request out to some server out in the world somewhere. So we have to set up the struct before we can do anything. So you can see here, I'm providing some extra headers. A lot of the times when you are using an HTTP client on a PC, all this stuff is kind of abstracted away. They usually give you constants that are actually representing the actual text contents of an HTTP request. So it might throw you for a loop if you've never actually manipulated header data exactly, with the text form itself. So it's kind of cool, but also like, oh, am I doing this right? Is the format correct? One thing for that headers array, or that array of pointers essentially, is making sure that it's null terminated. That's pretty important, or else it'll not work. You can see here there's the method, so post, put, get, so on and so forth. The URL is the publish path, so anything past the domain name. The host is the domain name again. So we're actually providing the host name twice to make sure that we're handling the TLS connection, and also we're handling routing of HTTP. We're using HTTP protocol 1.1. We're providing the message. The message is an array pointer to an array of characters. So that's something you got to make sure is that you're actually using char array. Remember, anything that's null terminated will essentially terminate the body of your data. So that will kind of restrict what type of data you have to send if that needs to be done in text. The response here is the response callback. So this is what you'll actually get. This is the callback that returns once your HTTP request is completed. And also you need to provide a receive buffer. And this is kind of tuned to whatever you need for your application. You need to make sure that your HTTP requests and responses are as small as possible, and you tune it to the maximum possible size for that request. So hopefully that makes sense. In this case, I think it just did 256 bytes, but you can make smaller or larger depending on the payloads that you are expecting. We are dealing with JSON, so that's important here. And we are setting those headers from before and just pointing it to the header fields. And then we're calling the HTTP client request, which is using that socket number, that FD, and we're using a reference to the request. We're setting a timeout as we need to. I think by default, I don't know if I included that, but I think it was 3 or 5 seconds. And that null parameter there is actually, if you want to, you can actually provide some context data in that null parameter, and that'll actually be provided to the HTTP client response callback. So you can kind of use it in there if you need to. In this case, I don't have any data that I want to share with that callback, so I'm just going to leave it null. Here is that response callback, and what I'm doing is I'm just printing out the status code. If the status code is not 200 or 201, I'm going to exit out of the callback because I'm getting an error, and most likely there's nothing to do if I am getting an error. If you need to do any type of error detection or any types of corrections in your code, this is where you kind of get that information. This is where you maybe call the callback to your main function and say, hey, I got a response, but it was not a 200 or a 201 or whatever code that you're expecting. So for a small payload, generally you're just going to get the final data here. Let me see. That in num, you can see up there at the top that that second parameter in the callback, that just provides you kind of like what the state of the call is, or that callback is. And in general, as long as you're receiving data within the buffer that you provided, you're going to get this HTTP data final. So all the data is in there, and it's ready for you to use. And the way you do that is the response actually provides a pointer to the beginning of the body fragment, or where the body is, and you can essentially decode that from that particular starting point. In this case, because it could be anything, I'm just putting just a generic device data. I'm setting it to false, and then as long as the cloud callback is defined, I'm just putting that data into it. And that's the same callback that I showed earlier that's actually being invoked in the main function. So hopefully I haven't lost you guys yet, but please let me know if you need clarification on anything. Because that function is a blocking function, it will basically call that callback, allow for any processes to happen. Once it returns, you're ready to close the socket connection. So we can close it using that POSIX command close with that socket ID. We're using the correct free function for CJSON. So the one I mentioned before, you can't use kfree for anything generated with CJSON. You have to make sure you use CJSON free, or it'll basically cause your application to bork, and you don't want that. And then at the end here, I'm just getting a log message to say, hey, everything was sent to the cloud. So we've used the POSIX connect call, which establishes the connection plus the TLS connection. So it's kind of like TCP first, then TLS, and then you can kind of use it to do whatever you want securely, which is great. We're setting up the HTTP request structure, which contains pointers to the data, what function, what method you want to use, callback information, anything that you would expect for an HTTP request. We handle the request response so that when it finishes, you're going to get some type of response back. You're going to get codes. You're going to get any body data, anything like that. You're going to be handling in that callback. You might be actually decoding in that callback right there. And then if you have valid data, then you can call back to your main function and provide that data to your main for whatever processing you need to do. If you need to, maybe it's a configuration for your device, so maybe you have to update that configuration, update timer values, things like that. Finally, when that all returns, you're going to be closing the socket and you're freeing any heap usage using the CJSON free. Or let's say you're not using the heap, then you don't have to worry about it. So that is the gist of that. So this talk was actually a little bit more about setting up a connection than actually using HTTP, but hopefully that gives you an example of when I think about connection to cloud, I think about I'm pushing data out to the cloud from my device. It could be sensor data, it could be anything like that. So using just the post command, you kind of get a general idea of how it works. You can do it. You can just change the method function for a get, and you don't have to include any type of body. And if you're getting data from a server, if you're just doing a get request, but hopefully that gives you an idea of, oh man, okay, I need to worry about the connection and make sure that it's secure, and then I can actually issue my HTTP request. So that's why a lot of times people will get, they're so, because this is one thing that maybe in Zephyr needs a little bit more love and needs to be a little bit made easier, kind of like UART. It's just like, this could be made a lot easier for people who are, especially if you're coming in and you're like, I would need to use HTTPS, and why isn't this easy? So hopefully it just kind of gives you an idea of how it works and the little sticky points that come with it. But because setting up a socket is like confusing, it's code intensive. If you're not using the right certs, you'll get errors. One thing that I actually spent a lot of time on, and I talked about this in a previous video, with which I will add to the description shortly, but doing a modem trace. So this is probably the first project where I actually utilized heavily the modem trace and also loading everything in Wireshark and looking at the whole TLS handshake process that I was dealing with, mostly because I was having issues connecting to the server, and it turned out to be some incompatibility between the TLS implementation on the device and the server, and it was like nothing I was doing wrong. If I switched to using a different server with a different cert, it just worked. So, but it's great to actually see the process in Wireshark. Be like, okay, I got the client hello, I got the reply, I got the ACK, I got the server hello. Server hello doesn't have anything. That's not good. Or server hello has, okay, yes, I agree on the Zephyr suite. Let's do this, so this, so this. Usually there's a little bit more included in that server hello, not just that like kind of reply. So this is probably going over your guys' heads, but modem trace, very helpful for the NRF9160. And so make sure that you keep your payload small and efficient, because we are basically using a text format. You want to make sure that you can reduce as much as possible. If it's going too crazy for you, if your TLS connections are getting too expensive for you, you might have to switch to a different protocol. So it doesn't, it's not friendly for binary payloads. So you can pull it off, but there's some extra, extra stuff that you got to work with there. So you got to convert it from binary to text representation, which is fun. That is it. I just wanted to let you guys know that the biggest discount for the year for the NRF9160 plus the air quality wing plus all the accessories on the Circuit Dojo website, so circuitdojo.com. It'll be the biggest discount all year, 20% if you guys are interested. So if you want to be in on that, you got to subscribe at jaredwolf.com. I will be sending out those codes, and that will be the only way for anybody to get them. So my voice is going. Let me see if there are any questions in the comments. I can stick around a little bit longer today. Voxorin, I've been working on converting my program to communicate with my server over non-IP. That's cool. Have you ever worked with NIDD at all? So that's one thing I haven't really gotten to or played around with, is like anything that's not IP related. I've done some device-to-device stuff, so Bluetooth, Thread, things like that, but like Thread is IPv6. So, but I've done some 802.15 or 804.15 to whatever the underlying layer of Thread is. So for device-to-device, but I have not played with NIDD, which is cool. I wonder if Zephyr has support for it. I'm going to add a note here. Zephyr NIDD. Mohammed, is there a good HTTP server sample on Zephyr? I don't think so. So if you want to host an HTTP server on a device, you might have to be playing around and doing your own thing. I don't think there is, but I haven't looked. I've only really concerned myself with the client. Now, if you're referring to more like an HTTP server that supports Zephyr, there's plenty of stuff out there. I'm actually using Caddy as a reverse proxy to other services and servers that I have behind it, and it works great. I'm using the TLS certificate, the CA cert for Let's Encrypt, so that has been working fantastic, and your mileage may vary depending on what server you're using and things like that. So Voxorin, I think Verizon offers NIDD right now. Is dirt cheap. Huh. Oh, awesome. I had no idea. I'll have to look into that. I've never heard of it. So I'm in my own world sometimes. And plus, yeah, I'm always learning though. This is fantastic. Thank you for sharing. I have it written down here right now. I'm going to play with it. Maybe it's something, I know there was a lot of lightweight M2M integrations and things like that, which uses CoAP underneath, and that's like a whole other world. It's not as user-friendly. It's not as like, you can't just spin up a server because it's just not so easy to work with, but that's neat. Thank you for sharing. So I think that is it for today. I hope you guys got something out of it. I know hopefully I didn't talk too much around in circles. I provided some clarification as to how to set up a connection, but also issue an HTTPS request. So thank you for being here, and I'll see you on the next rendition of Zephyr 101.